Okay, so now I want to take a look at a specific example of a dilation, specifically in a coordinate plane. So I graph the polygon ABC, I graph the triangle ABC. This is the pre-image, but I also want to graph the image after a dilation with a scale factor of 2. So similar to the last example, the scale factor is 2, so you could probably guess that the dilated figure is going to be twice as big as the pre-image. So here's what we can do. The center of dilation, if it's not given, the center of dilation is the origin, 0, 0. So that's the center of dilation. I'm going to label that point C. And then to figure out the coordinates of A prime, B prime, C prime. I could do something similar to what we just did, except it wasn't on a coordinate plane. I can make a ray through point A with the endpoint at the center of dilation, in this case, point C. Okay. One thing that you can notice is that the slope is going to be up 1, left 3. So I can go up 1, left 3 a couple of times, and then I know that my ray is going to go through these points right here. Up 1, left 3, that's basically 1 unit. This would be 2 units since the scale factor is 2. So this would be the coordinates of A prime. And then just repeat the process through point B. Okay, from the center of dilation, I go down 1, left 4. So I can go down 1, left 4 again. And then my ray would go through those points. Down 1, left 4 once is 1 unit. Down 1, left 4 twice. That's 2 units. Again, the scale factor is 2. So this would be B prime. And then lastly, I need to do the same thing with point C to find C prime. These are both points. This is a center of dilation. Maybe I should have named it something else like point P, but go down 1, left 2, and then go down 1, left 2 again. This would be C prime. And then here's the dilated figure. It should be the case, and I could double check that this figure is twice as big as this one. Easiest thing to check, in my opinion, is side length BC compared to B prime, C prime. This is 2 units. This is 4 units. It's twice as big. But here's what I'm going to do as well. A prime has the coordinates -6, 2. I'm going to actually compare them to the original or the pre-image ABC. B prime has the coordinates -8, -2. And then lastly, C prime has the coordinates of -4, -2. So that leads us to the coordinate rule for dilations. Before we talk about that, okay, you know that the dilation is going to be an enlargement if the value of K, enlargement, not enlargement, is more than 1, like 2, 3.5, 7/2, something like that. And it would be a reduction if K is less than 1, and then it also has to be greater than 0. Okay. But talking about coordinate rules for dilations, just like we have coordinate rules for translations, we also have coordinate rules for rotations. Each of those are pretty specific, kind of the same thing here. The coordinate rules for dilation is you're dilating a point P, as long as the center of dilation is the origin, or 0, 0, and the scale factor is K, then the coordinates of the image would be that scale factor multiplied by the x coordinate, and then that scale factor multiplied by the y coordinate. Let's go back to our example. So going back to our example, the scale factor is 2, the center of dilation, 0, 0, or the origin. So to figure out the coordinates of A prime, I could have taken a little bit of a shortcut and then just multiply the -3 by 2. Again, that's a scale factor, so that's -6. The 1 by 2 as well. That's basically Kx and Ky. So 2 times x, -3, is -6, 2 times 1, 2, and so on. 2 times -4, -8, 2 times -1, -2. And then that might be a little bit of a shortcut. Figure out the coordinates first and then graph the coordinates, as opposed to trying to graph the coordinates and then figure out the ordered pair.